So we've looked at arithmetic sequences. Now let's look at the notion of arithmetic series. Okay, when terms of an arithmetic sequence are added, they form an arithmetic series, and the sum to n terms of an arithmetic series, in other words, we were to add up all the terms to the fifth term, is given by this formula here. The sum of the first 5 terms, if n was 5, would be equal to 5 over 2 plus 2 times the first term by n minus 1 by times the common difference, which we've met these a and d before. Okay, so find the sum of the nth term, and hence find the sum of the first 20 terms, S20, of this series here. Okay, 5 plus 8 plus 11 plus 4. You can see that these mean it's an arithmetic series, not a sequence. Okay, but in this series, a is the first term, it's 5, and d is the common difference. 8 minus 5 or 11 minus 8 is 3. Okay, so we simply plug in our values to generate our sum to n terms rule. Okay, so we'll use this formula here, and we'll plug in our values for a and d, and we'll see that the sum to n terms rule is equal to n over 2 times 3n plus 7 for that series. So S, when n is 20, the sum of the terms, the first 20 terms, is 20 over 2 plus 3 times 20 is 670. Second example, given the arithmetic series 5 plus 7 plus 9 plus whatever, if the sum to n terms is 192, if I added n terms, I got 192. How many terms have I added? What is n? Well, we know a is 5, d is the common difference, is 2. We have our formula. The sum to n terms is given by n over 2, all of that. So we plug in, we know what our sum is, we've been told what that is, we're looking for n. So we put in our a value and our d value, and we end up here first of all. Okay, so just be careful here. 192 equals n over 2 by 2n plus 8. Okay, so let's get rid of this 2. We can do that by multiplying both sides by 2. Okay, so if I put a 2 there, these 2 would cancel. Okay, so I end up with 2 times 192 is equal to 2n squared plus 8n. Okay, so this 2 is cancelled out here. It's just algebra. So 192 then is equal to n squared plus 4n. So n squared plus 4n minus 1, 2 is all equal to 0. So we have this quadratic equation. We find the factors of that quadratic equation. They're equal to n minus 12 by n plus 16. Okay, we let n minus 12 equal 0, so we get n equals 12. So that means that if we add 12 terms of this arithmetic series, we'll get 192. Now we've also got n plus 16 equals 0, and n is minus 16. We can't add minus 16 terms, so we'll just get rid of that. We'll disregard that, as they say. So that doesn't matter, that bit. Okay, so the sum of the first 12 terms is equal to 192. And just something worth noting, that the nth term rule, or the value of the term position n, is also given by the sum of the terms up to that position n minus the sum of the terms up to the position n minus 1, the position just before it. Okay, so we'll just throw that in there. Just be aware of it if you come across it. Okay. Final example then. The sum to the first n, sum to the n term is given by s of n. S substitute is n squared plus 2n for an arithmetic series. Find S1, S2, and S3. That's the sum of the first term, sum of the first 2 terms, sum of the first 3 terms, And when you know that, write down what those terms actually are. Okay, so how do we do that? We're given this formula here. So S1, here we plug in our value, we get 3. So the first term must be 3. Okay, S2, plug in our value here is 8, but that sum of the first two terms is T1 plus T2 is 8. We know that T1 is 3, so T2 must be 5. S3, plug in our value for n equals 3, that tells us it's 15. Now we know T1 plus T2, plus, that's telling us that 15 is equal to the sum of the first three terms, T1, T2, T3, all equal to 15. We know what T1 is, we know what T2 is, so T3 must be equal to 7. So our terms T1, T2, T3 are equal to 3, 5, 7.